Discussed in last class, I shall start as per the syllabus. So I will be starting the first unit today. Here you can see the various topics of your first unit. We shall discuss the model of artificial neural, then neural network architecture, which was discussed briefly in last class, but I'll discuss again. Then what is called shallow network. Different learning rules will be discussed in this unit. Then how you can train neural network, that will also be discussed. After that, after this basic theory related to neural network, we will see various activation functions and loss functions related to this neural networks. And finally, we will see backpropagation and stochastic gradient descent for this artificial neural network. So we will not cover all these topics today. We'll go one by one in this sequence only. So I shall start with model of artificial neuron. Fine. So okay. So it was already discussed in last class that how neural network looks like and what exactly the neural network is. So though it was discussed in last class, let me discuss it again briefly that what it is. Neural networks, as we discussed, are used to mimic the basic functioning of the human brain. And they are inspired by how human brain interprets information. So this neural networks is used to solve various real-time tasks because of its ability to perform computations quickly and its fast responses. As we discussed in last class, these neural networks, they involve a huge amount of computation, scientific computation. So this, however, it has capability to perform computations very quickly, and as it performs computations quickly, it gives us responses fast, and so they have been very popular for real life applications. Now this artificial neural network, it contains various components that are inspired by biological nervous system, that also we saw in last class that what is the symmetry between biological nervous system and artificial neural networks. I'll not discuss the similarity again. This neural network, it has a huge number of interconnecting processing elements. Though this neural network, which is given in this figure, it looks very simple. The actual neural network, it has a huge number of interconnected processing elements, and these processing elements are known as nodes, which are known as neurons in our biological neural network system. So circles in this figure, they represent neurons in our biological neural network system, and they are called in this artificial neural network, this circles, they are called nodes. These nodes are connected with each other, which are other nodes, using a connection link. That also you can see in this figure, that is nodes are connected with other nodes in network through connection link. And the connection link contains weights. These weights contain the information about the input signal. So here you can see that one more, this first I included the simple one where you can see the input layer, you can see the output layer, you can see the hidden layer. This is blue one is hidden layer. And just for your knowledge, I have also included two more terms related to neural network in this figure, feed forward and backpropagation, which will be introduced later. Now here you can see that the same neural network, but the different representation here. This is input layer in this figure, which you can see that we can have number of inputs in input layer. So here you can see that X1 to Xn input nodes are there. And these are called nodes. Neurons are called nodes. And here you can see that these are the connections. And these connections, they have weight value. Okay. So why do we need this weight values? This nodes, this leaks contain weights, and these weights contain the information about the input signal, and each iteration and input in turn leads to updation of this weights. Sorry. Later, I will discuss that how we train neural network. If you remember, in last class we discussed that our biological neural network, it learns from experiences, learns from analysis and observation. So as we get more experiences, our learning increases and our accuracy in task increases, right? So similarly, here also we need to train artificial neural networks that it can perform tasks very accurately. So we need to train it. So we do not train it only once. We do not feed data only once. How we train the neural network? We feed data to neural network so that neural network can learn from that data. Okay. Now this data is not fed only once. In various iterations, we feed this data so that when it sees same data again and again, it can learn accurately from that data. So over iterations, like there will be several iterations, and each iteration and input in turn leads to updatation of the weights which we initially feed to this neural network. So initially we feed like W1, W2 up to WN. These are different weight values. So initially we set some values, like randomly we choose the weight values, and then during iterations, these weight values, the working of neural network is like that. These weight values, they get updated during the iteration. And once they get iterated, I'll explain this process, but they get updated during the each iterations. And after inputting all data instances from the training data, the final weights of the neural network, along with its architecture, is known as training neural network. So before, like, we have some architecture of neural network. We set some parameters related to neural network, and after setting those parameters, we set some values initially for parameters associated to neural network. Okay, and once we set this values initially, after that, we fit data to neural network. After every iterations, many of these values they get updated, and we go through several iterations until the neural network like it is converged, right? So this is like case goes through several iterations for better learning, and this process is called training of neural network. We are training neural network using data in training set. Fine. So this is how we train the neural network. Now, this training neural network is then used to solve specific real-time problems. Yeah, as defined in the given problem statement, like they are the trained neural networks are used to solve the problems. Now, there are several types of, like here you can see that. So here one more figure I have included here, the same one. Like here I have expanded this. This is same. You can see that the initial part is same, but the neuron, the circle, it is expanded, that how the computation is carried out. So you can see that x1 to xn, they are the input elements, and these are the weight values. So we multiply x1 with w1, we multiply x2 with w2, similarly xn to Wn. By mistake, this is W1, but this is Wn. Okay. So these are W1 to Wn, and they are multiplied. And after multiplication, they are added. So here you can see that for I is equal to 1 to n inputs, we are multiplying weight values with input values. And then the bias will be added to this function. Bias will be added to this addition. So this is like what is carried out in neuron, and then activation function, and then output. But as I told, activation function is one of the topics in your unit, which we will discuss later, that which are the various activation functions and what's the job of this activation function. So that we will discuss later. But here, like through this slide, I wanted to convey you that which are the layers, and what like input is multiplied with weight values. They are added, and then bias is added, and then it is passed on to next step in the training. Fine. So this is the basic architecture of neural network. Okay. Fine. So, okay, now there are several different types of tasks are there. Okay, types of tasks that can be solved using artificial neural network. They include like classification problems and prediction problems and so on. And we use artificial neural networks because they learn very efficiently and adaptively. Yeah, so I can see your hand, but I'll take your question after some time. I'll give you time to ask the questions. Okay, fine. So let me complete one short topic and then I'll take your questions related to this topic. Fine. Okay, so we use this artificial neural networks because they learn very efficiently and adaptively, and they have capability to learn how to solve a specific problem from the training data it receives. So just from that training data which we have, from that training data, it learns how to solve a specific problem. For example, suppose you have a data set of, for example, yeah, stock market. You have a stock, like suppose you want to implement stock market prediction. So you have past data which is fed to neural network. It learns trends and trends and insights from this data which we feed to the neural network, and then it be able to predict future market. Right. So this is how, like, it is trained using training data. After learning, it can be used to solve a specific problem very quickly and efficiently with very good accuracy. And some real life applications of neural networks, they include like air traffic control, optical character recognition, and like some scanning apps like Google Lens, voice
Mayra
recognition.
ma'am,
They also use neural network.
hello.
Yeah,
Mayra ma'am,
yeah.
sorry to disturb you. Actually, students and we are not getting your voice clearly. It's continuously your voice is getting glitch. So I think,
Oh,
is there
is it?
any technical
Uh-huh.
problem?
Uh-huh.
Yes.
Uh, so everyone is not getting, like, you have also experienced the same?
Yes, yes. Actually, I got the message from many students that we are not getting voice clearly, and
Okay.
I am not also
Okay, okay,
getting
okay,
voice.
okay. So should I rejoin? Let me leave once and let me rejoin. But otherwise, I am using the like a same setup which I used in last class, but maybe some technical issue. So let me stop one. Let me leave once and rejoin. Fine.
Okay, okay.
Yeah. So students, we discussed this basic architecture. Okay. Fine. So there are several applications of this neural networks. Okay, we have seen the basic architecture. Now let's see the types of neural networks which are available. There are several types of neural networks, but we will see the common types of neural networks, that how it looks like. This is again like another architecture of neural network. So this is architecture of neural network, and here I have included simple artificial neural network. So this is like a bit extension of this, that this is a neural network and this is perceptron and multi-layer perceptron. They are types of artificial neural networks, simple types of artificial neural networks. Okay, here are the common types of artificial neural networks, and you can see that the common types are feed-forward neural network, radial basis neural network, multi-layer perceptron model, which I just demonstrated, convolutional neural network, modular neural network, recurrent neural network, sequence to sequence model. These are the common types of neural network. Now, among these several types, some of them are very popular. Now, let me first briefly tell you again about the ANN. It is known as an artificial neural network. And if I talk about the popular artificial neural network, then it is a feed-forward neural network. It is a feed-forward neural network because the inputs are sent in the forward direction. Inputs are sent in the forward direction, and it can also contain hidden layers, which can make the model even denser. And this artificial neural network, they have a fixed length as specified by the programmer, and it is used for textual data or tabular data. And a widely used real life application is facial recognition for artificial neural network. And it is commonly less powerful than convolutional neural network and recurrent neural network. So initially we had only artificial neural network, CNN and RNN were not there, but the CNN and RNN were proposed and have been popular in last 1 decade. So let me briefly tell you about the CNN and RNN, and several extensions of the CNN and RNN are also available. So there are several types of neural networks, but among them, these neural networks have been very popular. Now, CNN is also known as convolutional neural network, or we can say that a convolutional neural network is abbreviated as CNN. This CNN is mainly used for image data, as I discussed in last class, and it is used for computer vision. And some of the real life applications are object detection in autonomous vehicles, etc. And it contains a combination of convolutional layers and neurons. So in this subject, you will mainly learn this convolutional neural network in detail. In remaining modules, this will be discussed in detail. And this contains combination convolutional layers and pooling layers and so on. And it is more powerful than both ANN and RNN. CNN is more powerful than ANN. ANN is basic architecture of neural network. So the CNN is more powerful than ANN and RNN. Now, what is RNN? Recurrent neural network. It is used to process and interpret time series data. See the difference. CNN is used to process image data and RNN is used to process time series data. And in this type of model, the output from processing node is fed back into nodes in the same or previous layers. I repeat, the output from a processing node is fed back into nodes in the same or previous layers. And the most common type of RNN is LSTM network, which is known as LSTM is abbreviation of long short-term memory network. LSTM, long short-term memory network. But you won't learn RNN and LSTM in this subject. That you may learn later in your future subjects. In this subject, you learn the CNN in detail. Fine? Fine. Okay, now we have seen in the basics of the neural networks. We know that neural networks learning capability is what makes it interesting, right? So let us see that how these neural networks learn. So there are three types of learning in neural networks. Before we discuss these three types of learning techniques through which they learn, let me show you that how do we feed data to neural networks so that it can learn from this data. So this is your basic, this is a architecture of neural network. And here you can see that arrays are used to feed data to neural network. Remember that arrays are used to feed data to neural network. Arrays of different dimensions. They are fed to neural network. So you can see that here that in input layer, several neurons are there, and each element of this array, like it would be one item of array would be input to one node in the input layer. So this is how data is fed to neural network. So whatever data you have, that is represented through array. Okay, now we have also discussed that we have neural networks to learn from different types of data. What can be the different types of data? The type of data may be text, it may be voice, it may be image, it may be video, right? The type of data, like data may be text, data may be image, data may be video, data may be voice. So we have data available in different formats. So if it is text, then it's very easy to represent the text using array. Now that data in the form of video and images. Okay, so now let me show you that how do we represent data if the data is in the form of image and video. Okay, so here I have included one example. Let us assume that you want to feed this cat image to your neural network. Now it is image. So how to fit this cat image to neural network so that it can learn the features of cat, or it can learn from this image. So you need to convert this image into in the form of array so that it can be fed to neural network. Okay, now as we all know, color images, they have three components, and these three components are three channels, three color channels. Okay, this image has three color channels. Which three color channels? This is blue, green, and red. These are the three color channels. Now, if I say that image resolution is, okay, here carefully. If I say that image resolution is 100 cross 100, So there are 100 cross 100 pixels, right? You must have heard this, that image resolution is 100 cross 100 or image size is 100 cross 100. Okay, if it is 100 cross 100, what does it mean? That in 3 channels it has 100 cross 100 pixels. In this example we have taken 28 by 28 pixels. The resolution of this cat image is 28 cross 28. So what does it mean? That all 3 color channels, they have 28 cross 28 pixels. So pixel intensity for red channel will be different, pixel intensity for blue channel will be different, and pixel intensity for this green channel would be different. So here you can see that what is the pixel intensity for all these 3 channels. You can see that we have 3 matrices. Okay, and here for simplicity, they are taken 4 cross 4. But if it is 28 cross 28 image, then there would be 28 rows in this matrix and 28 columns would be there in this matrix. Okay, and there would be 3 matrices. There would be 3 matrices, one for red channel, one for green channel, and one for blue channel. So if your image is 28 cross 28, then you will have, if it is color image of 28 cross 28, then you will have 3 matrices to represent that image, and this 3 matrices would be of 28 cross 28. So you can say that in short, okay, you can compute that what is the answer of 28. It is, I think, 28 cross 28 would be 784. Okay, so in one matrix, you have 784 values. Such 3 matrices are there. So 784 multiplied by 3. You can compute this if you have notebook. So 784 multiplied by 3, because 3 matrices are there. So total how many values or how many pixel values are there? 2352. 2352. So to feed just this one color image to your neural network, you need to feed to neural network 2352 values. So how many neurons are required in your input layer? 2352, because one value will be fed to one neuron in input layer. I hope this is clear to everyone. If I want to feed one image of 28 cross 28 pixels to neural network for learning, then how many pixels will be there? Like, as this is color image, there are 3 channels. For each channel is represented by one matrix, because those many 28 cross 28 pixel values, because intensity values will be different. So you will have 328 cross 28 matrices, and 3 into 28 into 28 would be 2352. So this many values you have to fit to your neural network. So 2352 values should be, neurons should be there in your input layer. Like this is your input layer. Then here there should be 2352 input neurons, so that you can fit 2352 values. Now this is about the color one image. Now what if you want to feed video to your neural network for training or to get insights from that video? So always when you want to feed a video to neural network, the video is converted into a set of frames or set of images. Video is converted into set of frames or set of images. So now when you want to feed one video, you have to feed your neural network multiple images. Then you will be able to feed one video, and you have just learned how to feed one image. So when you want to feed video to neural network, you have to feed a set of images. Okay, I hope you are getting this point. So this is how we feed a video to neural network for learning. So like this is about the data, that how the data is fed to neural network. Data is converted into array or matrix form. Like you can say that multidimensional arrays are used to feed data, and then the data is fed to neural network for learning. Okay, now before I move on, I would like to take your queries quickly, so that like we can finish topics also, or at the end, I am fine to take any number of queries. Okay. Okay, those who have raised hands, they can ask one by one. 3 students, they have raised
Hello,
hands.
ma'am.
Okay.
Am I audible?
Yes, yes.
मैम, मेरा क्वेश्चन ये है कि आपने 28 by 28 का जो इमेज लिया है वो
हाँ,
उतना खराब रेजोल्यूशन का क्यों लिया? मतलब क्योंकि अगर रेजोल्यूशन अगर अच्छा होगा तो ट्रेनिंग भी अच्छी होगी ना, तो हम ओरिजिनल
तो
इमेज को ही क्यों
एग्जाम्पल
नहीं
के लिए
डालें?
लिया है जस्ट टू एक्सप्लेन यू. आई एम नॉट सेइंग दैट वी आर फीडिंग ऑलवेज 28 क्रॉस 28 पिक्सल्स images. This is just an
हाँ,
example to explain you
ओके।
that how images are fed to. Today we are taking pictures using mobile phones, and when you take picture using mobile phone, they are in megabytes. So usually, like even if I consider 1 megabyte, then you know that 10 raised to 6 cross 10 raised to 6. Now multiply 10 raised to 6 into 10 raised to 6, it is 10 raised to 12, and this many pixels are required to represent like one channel of that color image. And you can imagine the number of neurons required in artificial neural network, in input layer of artificial neural network. And just to reduce this complexity, we have convolutional neural network, which I will discuss when I will discuss convolutional neural network. Fine, next question.
Hello, ma'am.
Yeah.
My question is that why always we consider to pass an array for because we know that in data structure we have many dynamic different what you can say store data structures. Why only we are using array in input type?
Can you please share that which other data structures are you thinking to represent the data, so that we can compare and I can tell you the differences, right? Because arrays have been considered when you want to represent data in different dimensions. I'm talking about dimensions, okay? So do we have any data structure which can be used to represent data in different dimensions?
Yeah, I got that.
Yeah, dimensions, because suppose it is matrix, or you can see that here I have written that color image is for to represent one color image, three-dimensional array is required. Three-dimensional array. To represent one color video, four-dimensional array is required. Tensor is nothing but array. In TensorFlow, if you have heard, which is Python library to implement machine learning models and deep learning models, we have TensorFlow. And in TensorFlow, tensor means array. Okay, so this is the like good architect, good you can say data structure to represent multi-dimensional data. Okay,
Hello,
next
ma'am.
question. Yeah,
Ma'am, I am audible.
yes,
Ma'am, you said that each node will accept only one element of an array.
yes,
Then all
yes.
the data which is fed to the input of the network is first stored for learning and maintaining history.
We are storing data for, suppose I want to feed one image to neural network. So one image, just I discussed that how it is represented, and there are 2352 values. So I need to represent these values by this array. And this array, each element of array is fed to neural network. So if there are 2352 elements, then I need those many neurons in my input layer.
Ma'am, then each neuron will store that each data.
It doesn't store. We discussed that each neuron processes that data. We discussed that input value is multiplied with weight value, and then summation happens in neuron, bias is added, and then this value is passed on to the next layer. So no values are stored in neurons, they are processed by them.
Okay, ma'am.
Yeah. Fine. So if there are more questions, we can discuss at the end of class. Okay,
Hello,
let us
ma'am.
move forward. Yeah, Pujan, you want to ask something?
No, ma'am, I am Kamal. I
Yeah,
have a
Kamal. This is last question in between of the class. Okay, then I'll take any number of question at the end of the class. Okay, tell
okay.
me your question.
Ma'am, how much FPS data from the video we provide to the neural network?
How many?
FPS
Sorry.
like अगर हमको वीडियो में से हमको इमेज देनी है न्यूरल नेटवर्क को, तो हमको
हाँ.
वीडियो पे कितने FPS पे देनी होगी, कितने फ्रेम्स में देनी होगी, एक
Okay,
एक
okay,
सेकंड
I
में
got
तो
it.
होगी।
Okay, frames per second you are asking, frames per second.
या
Okay.
यस मैम।
Now it is not like fixed number. Okay. It depends on, completely depends on your application. So you have to decide that what kind of data you want to extract, or what kind of learning you want to give to your neural network, and accordingly, like for example, in our one application, which is for dry eye disease detection, it was video of 12 seconds, and we extracted 1 frame per second, because we wanted, like we wanted to extract a particular kind of pattern, and it was possible only with, like, if we extract only 1 frame per second, then it had been possible. But suppose if you want more accurate data and more accurate features you want to extract from your data, then you may take more frames also. So it is not, there is no standard rule, or there is no standard, like number that you should take a frame per, like how many frames per second. So it completely depends on what kind of learning you want to give to your neural network, and for what kind of application you are implementing, and what kind of information you want to extract from your video. Yeah. So let us move forward then. Okay, so this is like, okay, now let's discuss the types of learning. As we discussed, we have seen the basics of neural network. Now let's see the types of learning. Okay, there are three major types of learning in neural networks: supervised learning, unsupervised learning, and reinforcement learning. Fine. So let us discuss briefly that how these three types of learning differ from each other. Supervised learning, as the name suggests, it is a type of learning that is looked after by a supervisor. It is looked after by a supervisor, and it is like learning with a teacher. When you learn from teacher, it is supervised learning. And there are input training pairs that contain a set of input and the desired output. We have training data to train the neural network. When it is supervised learning, associated with data, we have labels too. For example, in our previous example, I showed you that there was an image of cat. So when there is an image, there is a label associated with that image, that this is cat. If it is dog image, label is associated with that image, that this is dog. Okay, so when we feed this data to neural network, it knows that this is the image of cat, this is the image of dog, this is the image of zebra, and it learns, okay, zebra, these are the features, cat, these are the features, dog, these are the features. Similarly, suppose I want to train neural network to identify alphabets. So what I'll do, I'll have different pictures of alphabets written in different handwriting, and I will label with every character written by different people, with every character written by different people, I will have a tag associated with that data, that this is A, this is A, this is A, these are B's, these are C's, and so on. So I'll feed neural network A written in different styles by different people, but it will learn, okay, these are the features, these are the curves, right? These are the different styles. So it learns from that. So that is called labels associated with like input, and those labels are also called output, because we want, after training, we want neural network to identify the correct data when we feed it. Like when we feed unlabeled data, it should predict correctly that whether this is A or B or what. So we call this labeled data. And supervised learning means we provide supervised learning through labeled data. In supervised learning, output from the model is compared with the desired output. Okay, now when we give training, what happens? You give input to the neural network. Also, you give the output. Okay. Then after that, the output from the model, like what output the model is given, neural network is giving, it is compared with the input, and the error is calculated at the end of the iteration. That what's the difference? And this error, which is calculated, it is sent back to the network for adjusting the weight values. This adjustment is done till no more adjustment can be made, and the output of the model matches the desired output. And in this, there is a feedback from the environment to the model. So I'll show you one example for the supervised learning. Okay, so that it should be more clear to you. Now, here is the example. There are several examples you will find in literature for supervised learning. As I discussed, input variable is there, which is known as predictor variable also. And associated with input variable, output variable is also there. So suppose input variable is image of cat and output variable would be name cat. Okay. So this is how like we have a set of input and output variables. And this is the example. Okay, suppose I want to train this neural network, which is here. I want to, I want to train neural network algorithm to make it, uh, uh, yeah, to predict this, to predict that email is spam email or non-spam email. Okay, so what I'll do, I'll feed different examples of spam and non-spam emails to this neural network. It learns from that from subject and from contents of the email, from you can say source address of the email. It will learn from different parameters associated with email, that which kind of emails are considered spam email and which are like not non-spam email. Once it learns, like it is ready. Now model is trained, algorithm is trained. So it can be used for new email. Now when new email is coming, automatically it categorizes based on its based on its learning. It categorizes new email either into non-spam or spam. Okay, now every time, like first time when you are training model, you have passed data and you have trained it. But now it's not like the training is over. You will also have like future emails, and then again the trained network will be retrained with new samples. So a training will be increased and it will be more accurate to categorize your emails into spam and non-spam email. So this is how supervised learning works. I hope it is clear. Okay, supervised learning. Fine. This example we have discussed. The popular algorithms for supervised learning, like popular machine learning algorithms for supervised learning are decision tree, random forest, k nearest neighbor, logic regression. So those who have learned machine learning, they might have learned this algorithms. And if you have not learned, and if you want to get, if you want exposure to this machine learning, then you can later search for this algorithms. These are very popular algorithms for supervised tasks. And you can, yeah, fine. Okay, now let's see the unsupervised learning. That what is unsupervised learning? Fine. Okay, let's go back. Unsupervised learning. Okay, now what is this unsupervised learning? As name suggests, no teacher. Unlike supervised learning, there is no supervisor, there is no teacher in unsupervised learning. बहुत सारी चीजें आप अपने जीवन में भी खुद learn करते हो. It is not taught by your parents. It is not taught by your friends. It is not taught by your teachers, but you learn through observations and analysis. So that is unsupervised learning. Through observation and analysis, you learn. Okay. So in this unsupervised learning, there is no feedback from the environment. There is no desired output, and model learns on its own. So for example, if I take the same example of cat, then in supervised learning, you provide image along with label that this is cat. But suppose it is unsupervised learning technique for neural network, then you provide only cat image. You don't provide label that this is cat. It has to learn to differentiate between different images, that this is one type of images and this is another group of images and this is third group of or cluster of images. It learns its own on its own. Okay, and during the training phase, the inputs are framed into classes that define the similarity of the members. So how it differentiates between inputs, that it learns features from the input data, and it groups the similar inputs. It groups the similar inputs. So for example, suppose you are feeding, let me give you example. Okay, for example, there are different color objects. So it may group them based on color features, that these are red. For example, you are feeding different vegetables. So suppose suppose let's say tomato is there, let's say apple is there, orange is there. Okay, so what it may do that based on color and shape or only based on color, it may group. It depends on that how many input elements you are feeding, how many input data you are feeding to neural network. It may group that apple and tomato in one group because they are red in color, their shape is circle, right? Now orange may or may not be in the same group. Orange also has circle shape, but it has different color. So it depends that how many such data are there in your input in your training set, and accordingly it will like group them. So each class contains similar input patterns, and on inputting a new pattern, it can predict to which class that input belongs based on similarity with other patterns. So if there is no such class, then new class is formed. Suppose there is one input data for which no class has been created yet because it has completely different features. In that case, a new class will be created. So it learns on its own and it creates the different groups based on the features of that input data. That is unsupervised learning. Okay, I'll show you one example of unsupervised learning. Like here you can see that uh, unsupervised learning, you are feeding these characters to this a neural network. Okay, so what it has to do, like you can see that it identifies prominent features of Tom, such as pointy ears, bigger size, etc., to understand that this image is of type 1. It doesn't know that it is Tom image. It is for neural network, it is type 1 image having such features, pointy ears, bigger size, etc. Similarly, it finds such features in Jerry too, and it knows that this image is of type 2 because having some different features than Tom. Jerry has some different features than Tom. So it will identify Tom pictures as type 1 pictures. It will identify Jerry pictures as type 2 pictures. And therefore, it classifies the images into two different classes without knowing who is Tom and who is Jerry. So you can see that the based on similar features, like this 5 images are categorized in two groups. Similar features, like images having similar features in one group, and here is the second group, right? So even we don't know that how many groups will be created. It depends like how similar the objects or how similar the data are in our training set. So this is unsupervised learning. You can see that we are like this supervised learning. Supervised learning में हम यहाँ पे labels भी दे रहे हैं. This email non-spam email, this email spam email. So all the records in our training data set, they have associated with them output, like they have associated with them label. Spam or non-spam. So it learns, okay, this is called spam, this is called non-spam, and then we use it. But in in unsupervised learning, no labels. It has to learn on its own. So different types of techniques for unsupervised learning are clustering techniques, association rules, dimensionality reduction, and so on. So we have like several different algorithms available for unsupervised learning. Okay, now let's see the third type of learning, which is used for such applications, real-time applications. And this third type is reinforcement learning. Okay, now let me tell you what is reinforcement learning. It is completely different from supervised learning and unsupervised learning. Using reinforcement learning or algorithm, machine is trained to make specific decisions. Machine is trained to make specific decisions. The machine is exposed to an environment where it trains itself continuously using trial and error. Machine is exposed to real-time environment, and it learns, it gets trained continuously using trial and error. And this machine learns from past experiences and tries to capture the best possible knowledge to make accurate decisions. This type of machine learning or this reinforcement learning is comparatively different. I give you example. Imagine if you are lost or dropped off at an isolated island. You are lost at an isolated island. Now what you would do? Initially, panic. Yes, of course, because initially we would, because you don't know, you are lost at an isolated island. But as time passes, you will learn how to live on the island. It is isolated island and you don't know anything. So what you will do, as time passes, you may learn how to live on that island. Then you will explore the environment there. You will understand the climate condition there. You will understand the type of food that grows there and the dangers of the island, etc. So initially, you are panic, but as time passes, you learn all these experiences. You get exposure to environment. You understand the climate condition there. You will come to know that what are the dangers there, what type of food is available on that island, and so on. This is exactly how reinforcement learning works. It involves an agent. It involves an agent it is like you, agent means you, because you stuck on the island. So it involves agent, and that is put in an unknown environment. Agent in reinforcement learning is put in an unknown environment like island, where agent must learn by observing and performing actions that result in rewards. So this reinforcement learning is mainly used in advanced machine learning areas such as self-driving cars, AlphaGo game, etc. And to better understand the differences between supervised, unsupervised, and reinforcement learning, you can go through like several short tutorials or videos available on several popular web resources, or I'll share with you later to understand the differences between the supervised, unsupervised, and reinforcement learning. And I'll show you one example of this here. Like here, you can see that this is the link of Edureka. This is the video wherein they have explained the differences between supervised, unsupervised, and reinforcement learning. So here, as I told you, there is an agent. Okay, agent is put into the environment. Agent has to learn on its own that what are the dangers and what is good, what is not good. So here you can see that it has to, because in future it has to take decision on its own. So initially agent may take wrong decision. If wrong decision is taken, then penalty is like given to agent. Penalty is charged. Okay. And if right decision is taken, then rewards are given to agent. So observe, select action using policy, maybe right policy or maybe wrong. This is wrong path and this is right path. Okay, so action will be taken. If the wrong path is chosen, then okay, right path is chosen, then get reward. And if wrong path is chosen, then get penalty. So update policy accordingly. It learns that which are the wrong and right paths based on trials. It updates its policy, it learns, and it iterates until an optimal policy is found. So this is how reinforcement learning works for several real-time applications, right? So the critique, okay, so yeah, we have discussed about reinforcement learning, fine. I have briefly introduced these three types of learnings which are used for training the neural networks. Okay, sorry. Fine. And here you can see that these are the three categories of learning: supervised, unsupervised, and reinforcement learning. Several types of supervised learning algorithms are available, and popular regression algorithms are there. Decision tree, random forest, classification algorithms are there. Various classification algorithms like k-nearest neighbor, logistic regression, Naive Bayes. SVM stands for support vector machine, and so on. So what does it mean? When you have labeled data, you use supervised learning. But in many real life fields, we don't have labeled data. I give you example why we need unsupervised learning. Today, we are applying this machine learning and deep learning algorithms to various real life sectors. And for example, healthcare sector. Now in healthcare sector, we have data, huge amount of data today, but this data is not labeled. To label data of any real life sector, we need experts of that domain. For example, if we want to label healthcare data, we need help of medical professionals. We need medical experts to label that data, to accurately label that data. Fine. If we want to label finance data, then we need help of finance experts. Then only that data can be labeled. And in real life sectors, like many professionals, they lack time. So, and moreover, this data labeling is also time consuming task and it is cumbersome task. So it's not easy to label data accurately. So in many fields, we have data, but the data is unlabeled. And when we have unlabeled data, we do not have any option other than unsupervised learning. Okay, we can't use supervised if we don't have label data. So like today, I may go to radiology center and I may request doctor to provide me MRI scans or CT scans. But then who will label those MRI scans? Thousands of MRI scans. If you want to train your neural network accurately, then you need data in thousands, or you can say millions and billions, right? So, but you can collect this data in millions and billions, but then who will label that data? It is very cumbersome job, and you cannot, like you and me, cannot label because we do not have knowledge of different domains, right? We need training. Even if we get training, like this labeling is subjective. So it's very difficult task to accurately label data. And if you do not label data accurately, you cannot train your neural network accurately, and you cannot make it ready for automated tasks. Right. So this is like complete. It is based on that philosophy: garbage in, garbage out. If you do not label it accurately, then you are feeding the garbage data. It won't be able to learn accurately and it won't give you good outputs, desired outputs. So these are the like different categories: supervised learning, unsupervised learning, and reinforcement learning. These are the different algorithms. Okay. Okay, now here, like this is machine learning workflow, but the same steps are involved in deep learning workflow also, because it is learning. Only difference in machine learning and deep learning when we use this neural networks is, in machine learning, we have shallow network or we have like simple networks, neural networks. Architecture of neural network is simple, which includes one or two hidden layers, right? And when it is deep learning, again, it is learning, but the difference is in neural network, we have several hidden layers. It is architecture of neural network is deep. But otherwise, this flow is same. The process is same. Okay. So what is the flow? That you collect data, right? Then data is pre-processed. Then choose learning algorithm that which, like for example, supervised learning, we have KNN, we have SVM, we have naive Bayes. So choose the algorithm that using which algorithm you want to train your machine. Then train the model, like you have chosen algorithm, train the model. Once you train the model, you evaluate it. You need to validate it, whether it's working properly or not for new data. And once it is evaluated, you can use it for real life application to make real life predictions. So this is the normal process, which is similar to data science process, because I told you yesterday that data science and this machine learning, deep learning, they go together. And you will notice the same steps in your data science applications, that you collect data, right? Prepare data, then choose like these two steps. They are related to machine learning when it is data science flow, that choose machine learning algorithm or deep learning algorithm, train the model. So this is like where machine learning, deep learning are involved, then evaluate model and then use that train model for prediction. So these are the common steps of like deep learning or machine learning algorithms. Okay. These are like some more applications, though we discussed many applications. I think I can skip this slide, or I can give you a few real life. I can discuss some real life examples to make you understand that how this machine learning and deep learning are used in real life sectors. Fine. So here you can see that I have, okay, search engines. We discussed yesterday that how search engines, they use machine learning, deep learning. Email programs, they use this learning algorithms to filter spam emails, that also we discussed. Gmail makes use of machine learning to filter out spam messages. It uses machine learning algorithms and natural language processing both to analyze emails in real time and classify them as either spam email or non-spam email. The next, you can see that banks, how banks use machine learning or how banks use deep learning. They use this machine learning, deep learning algorithms to predict exchange rates, to predict stock markets, to predict loan amounts for customers, etc. Smartphones, all smartphone applications, like most of the smartphone applications today, they are either machine learning or deep learning based applications. Smartphones, they use this algorithms to recognize objects, to recognize faces, to recognize gestures, to recognize voices, to recognize music, etc. Even Facebook's auto tagging feature, which probably I discussed in last class, it uses machine learning. The logic behind deep mind face verification system, the logic behind it is it is machine learning and neural networks. DeepMind studies the features, facial features in an image to tag your friends and family members. Next application is robots. Robots, they use this machine learning and deep learning algorithms to localize themselves and to identify obstacles. Similarly, autonomous cars, they use machine learning and deep learning to drive, to recognize obstacles, to recognize objects, and so on. Video games which you play on your smart devices, they use this machine learning and deep learning algorithms to enhance the player's experience. That also I think I discussed in last class, that opponent is algorithm when you play these games on your smart devices. Adaptive telescopes, they use these algorithms to improve image quality. In healthcare, deep learning and machine learning, they are used to diagnose diseases, to create robots, to assist doctors, to develop new medicines for drug discovery and so on. So several applications you will find in literature, like for this deep learning algorithms. Okay. I think that's all for today. I can discuss shallow network, but because it is about it's about 7 o'clock. I can take your questions now. If time remains, then I can cover shallow network in brief. Otherwise, we will discuss next time. Yeah. One by one, you can ask your questions. I'm ready to take your questions. Please ask your questions.
Hello, ma'am.
Yeah.
I have two questions. First is that is it necessary that the data we are feeding must have the same size to categorize? For example, you have given the example of tomato and apple. So is it necessary that both the image we are feeding, the data feeding, must have the same size?
Yeah, we pre-process data and we convert all the images into same size. So this is part of pre-processing step. Like as we discussed yesterday also and today also, that we prepare, like if you see in this slide, data preparation means we filter noise from the data, we remove noise from the data, we handle duplicate records, then we also convert them into same format. But because suppose in healthcare domain, you are collecting MRI images from different radiology centers. Now they may have different machines, they may have machines of different configuration. So their images will also be in different formats and different sizes. So when you want machine to learn like uniformly from all these images, then you need to pre-process data, you need to convert them into uniform format in uniform size, etc. Okay, next question.
Hello, ma'am.
Yeah.
My question is, if we have to feed data in audio form, then how can we use array in that case?
Audio is represented by particular form. It is a signal, right? We usually say that it is audio signal. And if somebody is there from electronics background, they know that how signals are represented. Okay, 0, 1, and like there is a particular format. So your voice is converted into that format, and then data is fed to neural network. So you can later you can search in Google that how voice is converted into how voice is fed to neural network. You will easily find answer. Representations are there, and that the representations you need to know. Okay, next question.
Hello. Yes, ma'am. I have a question from previous slide from that image
Huh.
one. So if we are missing pixel in an image, so how it's gonna work with that?
Supervised learning. Okay, you want to,
No,
okay,
no.
your
Yeah.
question is if data is missing. Yeah, there are different ways
Yeah.
to deal with missing values. So if you have learned data science, then you must be knowing. If you have not learned, then this is a question related to data science, that how to deal with missing values. So for missing values, sometimes we use median value. Sometimes we make a different model. We train that model to predict the values for missing cells in our data. We sometimes remove also if there are several. For example, I have collected student data or employee data, and if I find a record in which several values are missing, then I can remove it. But we cannot remove, like we need to check. There are several parameters which we need to take into consideration when we deal with such missing values. For example, I'm taking very simple example. In real life, we don't have only 100 records. But for example, suppose we have 100 records. We have collected 100 records. Now, if there are only 2 records in which there are missing values, we may remove those records. Because out of 100, if we remove only 2 records, it won't hamper the quality of data or size of data much, right? But if there are, suppose, 50 records or 40 records in which one or other values are missing, then we cannot remove those records. So one way to deal with missing value is remove those records. Second way is we sometimes use median value. We sometimes use mean value. So what kind of technique we should use? Like there is no standard rule that we should use this technique or that technique to deal with missing values. We usually, what we do when when we work on project, we experiment with each type of technique. That what happens if we delete those 2 records, if there are few records having missing values, what happens if we replace those values by some fixed value? Okay, what if we replace that value by mean value? What kind of results we get? So we check the results, we compare the results, and we observe that with which technique we are getting the satisfactory results or good results, and then we finalize that this should be the technique for our data to deal with the missing values. So there is no standard rule that if this is the application, that this technique should be used or that technique should be used. No, not like that. Several techniques are there. Sometimes not even only that fixed value or median value or removal of record. Sometimes what we do, for example, there are 50 records having full values, and there are 50 records in which missing values are there. So what we can do, we can train one model with those 50 records, and we can use that trained model to predict the value of those missing cells. So that is also one popular technique. So different techniques are there, and we can use any of them. Next question.
Hello, ma'am. Good evening.
Ma'am, is there
Huh.
Hello.
Yeah, you can ask one by one, no problem.
Ma'am, am I audible?
Yes. Yes, you are audible.
मैम जैसे कि आपने कहा था कि रीइंफोर्समेंट जो ट्रेनिंग है, रीइंफोर्समेंट
हाँ
लर्निंग,
हाँ
उसमें जो डिवाइस है वो अपने आप ही सारा डिसीजन ले सकता है।
हाँ, अल्गोरिदम मतलब हमारा
हाँ,
हाँ मतलब
तो
हम
वो डिवाइस,
ऑटोनॉमस कार में हम वो अल्गोरिदम
हाँ,
यूज करते हैं।
हाँ,
हाँ
तो जो डिवाइस है वो अपने आप ही
हाँ
डिसीजन ले सके, उसके लिए तो हमें
हाँ
कुछ डेटा इनपुट करना होगा ना डिवाइस में, तो
कुछ
वो एक
डेटा
टाइप का
हमारे
सुपरवाइज
पास
लर्निंग
नहीं है
नहीं
डेटा.
होगा।
No, we don't have data, and that's why we are using. See, okay, this is very good question. Let me tell you one difference between these three types of learning. See, we may have data, we may not have data. We may have data, we may not have data. First two categories. If we have data, then again two possibilities. We may have labels for the data, we may not have labels for the data. So now we have three types of scenarios. We have data but labeled, use supervised learning. We have data but not labeled, use unsupervised learning. We don't have data, use reinforcement learning. And it learns on its own. I told you that it learns on its own. Now, when it is learning on its own without data, it may make mistake. right? If it makes mistake, then penalty will be charged. If no mistake, then rewards will be given. So it learns that, okay, this is the right decision it has made, this is wrong decision it has made, and accordingly it updates its policy, that what it has to do in future when the similar when it comes across the same scene. Okay, next question.
Hello, ma'am.
Yeah.
In supervised learning, we have to split data in training and testing. Okay. Then what is the common ratio of training and testing data? And if we manipulate that ratio, how much it can affect the algorithm quality?
Yeah, it affects. We have to test with different ratios. The common ratios used are 30-70, 20-80, and 90-10. Usually 80-20 and 70-30 are used. That is 70% data is used for training and 30% data is used for testing. Okay, second is like 80% data can be used for training and 20% can be used for testing. So these are the common ratios. But again here, like there is no standard ratio for training and testing. You should experiment with all three different ratios and you should check that for which ratio it is giving you good results, like less misclassification. Good results means less misclassification or less wrong predictions. So accordingly, you can like fix that this is the good ratio for my application. Yeah, I hope I answered your question.
Hello, ma'am.
Yeah.
Is there possible we can pass video and audio both data at the same time?
We can pass different types of data, but it is like a slightly different theory. We can pass because ultimately data is presented in the form of array. So you can create array which represents both type of data, because image means what? Image means you are converting the data into numeric value and then you are feeding that data. Similarly, voice means what? You are converting that data into numeric value and then you are feeding. So you can surely pass different types of data together. Just you need to you have to make sure that what kind of representation you will use so that you can pass that data in one go.
मैम मेरा क्वेश्चन ये है कि मैं जो पूछना था, जो न्यूरल नेटवर्क है वो मैं बोल रहा हूँ, क्या वो सही है? देखिए, हम पहले n इनपुट्स लेंगे, जो आप शुरुआत में जो स्लाइड्स आपने दिखाई थी उस पे मैं बोल रहा हूँ। हम पहले n इनपुट्स लेंगे, फिर हम रैंडम वेट से उसको मल्टीप्लाई करेंगे सारे इनपुट्स को, फिर उसका जो सम है उसको हम हिडन लेयर्स में पास करेंगे। फिर हिडन लेयर्स में क्या होता है वो मुझे नहीं मालूम है, वो मुझे नहीं समझ।
That discussion is yet left.
हाँ, और फिर हम आउटपुट देंगे, तो वो जो आउटपुट होगा बस यही होगा ना कि वेट्स का जो भी मल्टीप्लिकेशन है और ये जो सम है, ये जो पूरा बिग पोलिनोमियल बनेगा।
There is a significance of bias and activation function and loss function, which we have not discussed. So I think up to this point, it is very simple and clear that input values are there. Weight values we randomly define initially. Multiplication happens between input value and weight value. They are added here. After addition, bias is added. Now, what is bias? That you don't know. After that, activation function. What is activation function? You don't know. Right? And then loss is calculated, comparing the output with the label associated with this input.
हमने यही इक्वेशन क्यों लिया? हम सम ही क्यों करते और फिर उसको वेट के साथ मल्टीप्लाई क्यों करते? क्यों इक्वेशन ये पोलिनोमियल ऐसा क्यों है? क्यों कोई दूसरा पोलिनोमियल नहीं यूज किया जाता?
So maybe like when this was invented, it is tried like this, right? It was compared with how our learning happens. It was compared with that. And maybe like initially, those who have invented this concept, they tried different mathematical functions also. They may have tried and then they have like proven. This is proven theory. Okay, if it works, if you implement this mathematical function, then it learns. So it is not like one go it was decided in one go that this should happen or weight should be multiplied, or no, it's not like that. Research goes on on this networks, on activation functions, on loss functions, many new things are proposed, right, based on experiments. So maybe initially all experiments were carried out and then it was proven, okay, yes, if you do like this, then it gets learning and it हाँ
मतलब हमारे पास पॉसिबिलिटी है कि आगे चलकर फ्यूचर में मतलब इसमें भी चेंज हो सकते हैं इन जो
आप
करंट
कर
मॉडल
सकते हो. You can experiment and you can check that what happens if you change this mathematical operations.
है
Usually this
yes.
operation is used. So you can experiment and you can check that what happens if you use instead of, for example, instead of multiplication, if you use division, or if you, what are the basic mathematical operations? The basic mathematical operations are multiplication, division, addition, and subtraction. So you can apply different mathematical operations and you can check what output you are getting. So it is like this earlier also, this was experimented and then it came out that no, this is the way how it learns.
Okay, thank you, ma'am.
Yeah. Okay, any other question?
Yes, ma'am. Am I audible?
Yes, you are audible.
Ma'am, can we say that ChatGPT, Google Assistant, and all are the examples of reinforcement?
No, they are examples of like not reinforcement learning. They are examples of this supervised learning.
How?
So past data is fed. For example, आप भी जानते हो कि पहले आप Google में query लिखते थे. How many? I don't know how many of you were using Google search engine 10 years back. हम यूज करते थे. So when we were using that time, it was not possible for Google search engine to help us to complete our query. आज आप एक query लिखना चाहते हो, when you type 2 words, it tells you that what's your query. नीचे आपको बहुत सारे suggestions मिलते हैं कि do like whether your query is like this. For example, आप लिखते हो कि हाँ, for example आपने लिखा machine learning techniques और machine learning in. सिर्फ आप इतने 3 words लिखोगे machine learning in, then it will show you in healthcare, agriculture, industry, and so on. Right? So how it has learned, जो पहले हम query type किया करते थे, they have recorded all these queries. They recorded all these queries. Using this data, they trained this model कि machine learning in के साथ ये query type हुई है. Machine learning in healthcare, machine learning in education, machine learning in agriculture. So जैसे जैसे जितनी भी queries हम type करते हैं, this data is recorded and this data is fed to neural network. Right? And it learns कि okay, machine learning in के बाद ये possibilities है. It has learned. So it shows you all those possibilities. Okay, so all this, like even when you ask a search engine through your voice, right? पहले बहुत सारे misclassification होते थे कि आप कुछ पूछ रहे हो और वो कुछ आंसर दे रहा है. But now it doesn't happen because it has learned different accent also. So it learns, like अभी उसको पता है कि ये जो आप बोलते हो, like like pronunciation is different, we know, right? So when I say thank you and sorry, and when you go to Europe and when they say thank you and sorry, their pronunciation is different. But even if they ask the same question and if we ask the same question, the pronunciation is different, but Google search engine understand that this is the query and it answers it correctly. So like उसने अभी भी it is in learning phase. जितना भी हम पूछते हैं Google Assistant को, उतना record होता है and they feed this data for incremental learning. तो वो इंक्रीमेंटल लर्निंग हमेशा रहता है. जितना वो लर्न करता जाता है उतना वो एक्यूरेट बनता जाता है. अब जितना भी गूगल के थ्रू करते हो वो रिकॉर्ड होता है.
ओके, तो वैसा भी हम कह सकते हैं ना कि वो रीइंफोर्समेंट कह सकते है ना, क्योंकि जब भी वो मिस्टेक करता है तो वो उसको.
No, it is not reinforcement learning. I clearly told you that we don't have data, then only we apply reinforcement learning. Here we don't apply reinforcement learning. Here there is no concept of penalty and rewards. Okay. So do not mix these two concepts. I clearly told you that reinforcement learning is used when we don't have data. So like AlphaGo game, then that autonomous cars, they are the examples of reinforcement learning. उसके लिए हमारे पास कोई डेटा नहीं था और हमने ये किया है ट्रायल एंड एरर बेसिस पे. नेक्स्ट क्वेश्चन. Yeah, Devika, you have question?
Hello, ma'am.
if yes.
If we can say that के जब डेटा आ जाएगा reinforcement learning algorithm के पास, तब वो उसके बाद सुपरवाइज फॉलो करेगा.
Do not mix it. I repeat, it is a separate learning technique. डेटा आ जाएगा तो reinforcement learning नहीं चाहिए हमें. Then we can like use supervised and unsupervised. Okay, so please do not mix it. It is very clear. When we don't have data, we can use reinforcement learning. Data aa jayega, then we don't need to apply reinforcement learning. For initial learning, we may use reinforcement learning, but I think your question is, initially we don't have data, so we are using reinforcement learning. And I think you mean to say that later, if we will have data for that application, we may replace reinforcement learning by other types of learning. Yeah, that may be possible. But initially, when we are developing, when we are automating any task, and when we don't have data, we have to use reinforcement learning. I hope you are getting my answer. Devika? Okay, next question. Paras?
Yes, ma'am. Yes, ma'am.
Yeah.
As we discussed that there are different techniques to fill the missing values. Yeah, so they need to be supervised or it will learn it by itself.
For what here you are asking for supervised? I didn't understand. Sorry.
Yeah,
It is
as
a
we discussed
different
earlier,
thing, na?
for that missing value.
Missing value कब होगी जब आपके पास डेटा होगा?
Yeah.
Suppose आपके पास डेटा कलेक्ट किया गया, हम बहुत बार ऐसा करते हैं ना कि फोन नंबर मांगा है लेकिन वी डोंट वांट टू गिव.
Yes.
कोई सर्वे है एंड दे आर आस्किंग फॉर ईमेल एंड मोबाइल नंबर टू एंड वी डू नॉट फील, we don't want to reveal our mobile number and email ID, right? And other data we fill, नाम और जो भी है, जो भी मांगा है. Okay, it's clear that you have data, but some values are missing. Okay, now tell me your question.
Yeah, for that data, we need a regression line XYZ. So for that techniques, the network needs to be supervised or it will learn it by itself.
How it can learn it by itself? It must be, please, I think you have not learned data science, so these questions are there. I request all of you to note down the steps which I discuss. If you are not noting down and only hearing, then please note down the steps, because yesterday also I told you the steps: that data collection, data preparation, which involves this data cleaning and dealing with duplicate values and dealing with missing values. Then we train machine learning model. So then we have to decide that whether it would be supervised or unsupervised.
Yeah.
So it doesn't have like, it is different step. It doesn't decide that whether learning would be supervised, whether we have labels for the data or not. If we have labels, then supervised. If not, then unsupervised. But I told you steps yesterday that we gather data, carry out exploratory data analysis, and then data is prepared. Now data is prepared because we have refined that data. If missing values are there, we have filled values or we have dealt with them. If duplicate values are there, we have dealt with them. If noise is there, we have removed the noise, right? Whatever like problems are there with our data, we have dealt with all the problems and we have like refined the data and we have data ready, right? So now we have to decide that whether we should use supervised or unsupervised. So it doesn't have any relation with this like missing values and duplicate values and so on. Type of learning has no relation with this problems in data. Type of learning can be determined based on whether data is labeled or not. That's all.
Okay. Thank you, ma'am.
Yeah. Okay, any more question? So I request you like to go through the fundamental steps of data science also, because as I told you, these are associated with each other, these two subjects. data science and machine learning, deep learning. They are associated with each other. So machine learning, like it's okay if you don't have preliminary knowledge. I discuss types of learning. I also discuss the steps of machine learning process, which are similar to the steps of data science process. And this deep learning, it is similar to machine learning, only the application areas are different. Fine. Thank you, everyone. Thank you so much for patiently hearing. Now we will meet next Tuesday. Thank you.
Okay, thank you, ma'am. Dear students, if you have any more questions, then you can just note down it and you can pass me. Definitely, we will discuss in next lecture. Okay. Right now, we can leave the meeting. Thank you all.
Thank you. Thank you, everyone.